very much, Maya, for the introduction. Welcome to the post-fight session. I know it's always difficult to concentrate after such a wonderful meal, which makes my work harder because I have to make sure that everybody keeps awake. So if anybody who feels bored, please raise your hand and we can just stop for a moment and give time for everybody to feel fresh and up again. So today's topic is about mental and behavioral disorders in neurodevelopmental syndromes, and it's a very important subject for neurologists and pediatricians, GPs, psychiatrists and psychologists, and all of the other professions who are involved with children and adolescents, because of the fact that these disorders are often missed and overlooked and not picked up at an early stage. And as I will demonstrate to you through this presentation, that it's vital that these disorders are picked up early and early intervention takes place, which actually helps the prognosis. It can make a lot of difference in these children's and adolescents' lives. So that's what I have to say regarding the introduction of my topic. So I should start with the slides. The layout of my presentation is going to be, I'm going to briefly touch on normal neurodevelopment, then I'll talk about a bit about etiology, definition and classification, epidemiology, characteristics of these disorders, common signs and symptoms, and a very brief reference to the treatment. And it could be, a lot of the material I'm presenting, maybe the stuff you may already know, so it could be a kind of revision and a reminder as well. Sorry, I did not this one. The CS development takes place from conception onwards through childhood and adolescence, and it slows down during adulthood, and as we age, it deteriorates. The main purpose is to acquire skills and abilities necessary for life. Oh, sorry. So this is how our brains look like. It's got different areas for different functions. They're interconnected with one another, and these pathways are modulated through neurotransmitters. And talking about the normal neurodevelopmental process, it starts from neurogenesis, which follows cell migration, and that's followed by synaptogenesis and myelination. I know it's a very busy slide and I don't want to go into the details, but the things which I would like to point out are the neurogenesis. Previously we thought that neurogenesis would stop around 25th gestational week, but now there's an evidence to suggest that in adults as well, the tendon gyrus of hippocampus, which is related to memory and learning, and subventricular zones of interventricular, which are related to olfactory lobes, actually keep on developing neurons even later in life. Synaptogenesis is another important area to consider. So it continues from 18 gestational weeks to adolescence, but it spreads off, it kind of maximizes from the age of 2 to 4 years. So a lot of synapses are being formed, and initially what tends to happen is that almost the number of synapses which are formed are almost double of what we see in the adult brain. And subsequently, myelination takes place, which means covering of the axons with a myelin sheet to protect it from short circuiting. A very important process is synaptic pruning. What it is, that it's the removal of excess synapses, and it brings down the number of synapses to almost half, which continues on in the adult life. And this is a really vital process to think about once it comes to treatment modalities, which I'll talk about towards the end of the discussion. So it kind of takes off very quickly from 2 years onwards, and it continues till around 10 years at a very rapid pace. And as you can see from the picture, here are the neurons, right? And these are there. Then you can see that there's lots of them over here. Whilst this becomes more thin, so that means that now the synapses are being pruned. And the purpose of neuronal pruning is to refine neuronal circuits and improve efficiency. And it's activity drawn, so the circuits which are being used, actually they remain active. The ones which are not used, they are lost. This is particularly important for the neurodevelopmental disorders. There is an evidence that the postmortem studies of the prefrontal lobe in schizophrenia reflect a small number of synaptic junctions and synapses, and it's considered that it could be the over-pruning which may be leading to that. Whereas in autistic epilepsy, we see a lot of synapses, redundant synapses which haven't been pruned, and that could be due to under-pruning. Right. Another thing to consider is that the different parts of the brain continue to develop through adolescence, late childhood and adolescence. As you can see, the frontal lobes, they are fully developed by 11 to 12 years, and temporal lobes, they take around 16 to 17 years to develop fully. Whereas parietal and occipital lobes, they continue through adolescence. And the associated neurodevelopment, if you see, it starts from conception onwards, from neurulation, but then it takes off from around birth time to around 1 to 2 years, especially if you're looking at the sensory motor cortex and perceptive and expressive language. And it kind of then slows down around 2 to 3 years, and then gradually it still continues to grow, but it grows at a slow rate. Whereas the higher cortical functions, as you can see, they reach the peak level of developmental speed at around 2 to 4 years, and then taper off more slowly. So they're continuing to develop at a faster rate, at a slower rate than our sensory motor and language cortices. And I'm sure most of us would be familiar with this picture. This is a picture of milestones of development which we see in children. So the children acquire different milestones for motor development, cognitive development, language development over a period of time, and we judge by those milestones if they are developing appropriately or not, and whether any development is slower than the normal. And I won't go into the detail of it, I just want to demonstrate that the neurodevelopment we talked about is linked to child development. And then it leads to something called as adaptive functioning, and this is a really important concept or construct to think about. So adaptive functioning is age-appropriate behavioral skills required to meet and navigate through everyday needs of life effectively. So these are every things we do, which we, starting from conceptual, like use of language, reading, writing, maths, reasoning, memory, to interpersonal skills, ability to make and retain friends, to practical skills like personal care, schooling, driving, money management, finding your way across the city. So all of these things we do are considered as adaptive skills. And this is one of the paramount features of neurodevelopmental disorders, because these adaptive skills would be affected in one way or the other. And it's also important to remember that they have to be age appropriate. Like a 4-year-old child cannot be expected to cross the road on their own, but a 14-year-old child can easily do that. But if a 14-year-old child cannot do it, that means he has a deficit in his adaptive functioning. So this is really important to think about the concept of adaptive functioning. So just to, in this section, just to summarize that we have looked at different processes in the neurodevelopment which take place for our central nervous system to develop properly, for it to make us ready to learn adaptive skills and to make us grow in life so that the skills, we continue acquiring these skills to make us compatible with life. Any questions at this point or any comments? Okay. So, but things do not always go as we planned. They never will. Things go wrong. So what happens is, there could be problems with the genes. Genes can cause problems. There could be problems with the environment which can affect our genes and make us different from the others. So I wanted to firstly touch upon this concept of the gene effect. That there could be single genes which could be affecting the process of neuronal development, or there could be a host of multiple genes doing that. But if you look at this slide, it would show that sometimes the individual genes actually would affect multitude of processes, many different areas of brain, many processes, where on the other hand, multiple genes may be affecting only one process. So this is an important concept to think about. So we all know about genetic disorders. Things go wrong. So there are mutations, there are deletions, there are a lot of things going on once the embryo has been formed. I will not go into that, but just to give you an idea that there are chromosomal disorders, there are single gene disorders which are called monogenic disorders. There are X-linked disorders, but the most important one which I would like to focus on from our perspective are the polygenic disorders, because most of our mental and behavioral disorders are related to multiple genes, not a single gene. And that makes it difficult for the future. I mean, obviously it is a challenge for research and for treatment in future as far as gene therapy is concerned, because they are polygenic disorders. And then there is a crossover between the genes as well. So as you can see from this slide, the genes of ADHD can also be seen in other disorders. So the other disorders could be caused by similar like ADHD, and the same is true with autism spectrum disorder. So the effect of environment on genes is really important. And that's where we talk about a subject called epigenetics, which means the environmental influence on gene expression with a little effect on DNA structure through chromatin alteration. Now that's a very complicated thing, I won't go into that, but what I would say is that there are processes which actually activate or silence genes. So for example, there's a gene for the color of the eye, right? And it wants the child to have a brown color in the eye. So the DNA, the gene, would trigger transcription. So basically it would actually transcribe the RNA to instruct the polypeptides to produce that color, right? So at that stage, what tends to happen is that there are certain processes which can activate or silence that promoter gene transcription. It can actually enhance it or it could stop it. So that means that the disorders can be initiated or stopped. It's very important in oncology where the cancer studies, they look at it and they see that the different genes have been triggered by some environmental factors leading to, some kind of production of cells from stem cells. So this is a very important process. And if you look at it, sorry, I have to go back. Yeah. So there are different kind of agents which may act during the developmental period, which may lead to this activation and silencing. Oops. And that's a list of all of those factors. The important ones I've given on this side, which are, things like infections, toxic metabolic causes, and so on. The other thing I want to say to you is that the two disorders we are interested in, autism and ADHD, are highly heritable. As you can see, the heritability rate in autism is around 76%, and it's 90% for autistic spectrum disorder. Right. Any comments or any questions? Any ideas? No. Maybe later on. Okay, that's fine. Yeah. I just want to check if everybody is I'm going at the right pace and if I'm making sense. Is that right?
I have a genetic question for the last. The ADHD and ASD are multi-gene disorders.
That's right.
How can they have a higher heritability as a dominant disorder, which is only 50%?
Yeah, I mean, I think the thing is because of the fact that there are loci of that on different chromosomes, which actually, for example, Rett syndrome or Fragile X, they produce symptoms like ASD. And equally, so there are correlations between them, and they are likely to be, they are kind of passed on, basically, that's what it is. And they have an X-linked connection there on the X chromosome, and I think that's the fact, that's the thing which keeps them going. So they are quite on a similar range to that of Fragile X disorders, basically, where we see these autistic conditions. Well, thank you very much for the questions. Now we come to the definition and classification of neurodevelopmental disorders. So they have an onset in developmental period, which is childhood and adolescence. So that's important. So they can start anytime from conception onwards to develop adolescence. And we need to think about what developmental period is. So for the purpose of classification, we say 18 years. I mean, that's considered because a person becomes an adult at 18. But if you look at the frontal lobe growth, it continues till 21 years, actually. So you can extend it a little bit. But for legal purposes, for the purpose of classifications, it's around 18 years. They arise from the impairment in normal CNS development. There could be local and global impairments of cognition, sensory, motor, regulatory functions. And they result in disability and social handicap. And that's really important, because we need to consider impairments alongside disability and social handicap, because a lot of us are dealing with disabilities because we cannot correct the impairments, I mean, until now, because of the fact that they're beyond us. So we need to look at that side of things. People would be familiar with DSM-5, which is a Diagnostic Statistical Manual version 5, which is a US classificatory system for mental and behavioral disorders. And as you can see, it divides, there would be two categories of disorders there, global and local. So in the global disorders, there is a global impairment of function, and there is intellectual disability is an example, where intellectual function is globally impaired across the board. Whereas there are local disorders where specific functions of brain are affected. Things like communication disorders, ASD, ADHD, or specific learning disorders. So coming to the prevalence of disorders, intellectual disability, at any given time in any population, 2.5% of people would have intellectual disability, irrespective of where we are, what culture it is, what country it is, what population it is. And most of them would belong to the mild group, which means they would have mild intellectual disability, almost 2%. And 0.5% would belong to moderate to profound group. ADHD, 8 to 9% of children, and that's the kind of aggregate of different studies, because different studies have thrown up different prevalence rates, but in children it's now considered 8 to 9%, adults 3 to 5%, and males are overrepresented. In ASD, the prevalence is 1.57%. Again, males are more represented, and almost 55 to 60% would have an intellectual disability. And 10% of this ASD group would have exceptional talents, like talents in music, mathematics, and sometimes people surprise how talented they are even having ASD. So it's interesting to see that the males actually make more once it comes to the prevalence of neurodevelopmental disorders as compared to females. So that's about thinking about some protective factors. So characteristics of neurodevelopmental disorders, they are spectrum disorders. So that means they would cover a range from mild to severe end. So there would be high functioning to low functioning. They would be mild to severe. So their symptoms would vary in severity. And they would also differ in range because of the fact that we know that ADHD has got different subsets, subcategories, subtypes. So there would be different symptom complexes and different subtypes. Other thing to think about is that neurodevelopmental disorders are pervasive across most settings, which means they would be prevalent, they would be present in most settings. However, the important thing to consider is that they do react to environment. We know people with autism, especially with sensory integration difficulties, find it difficult to cope with noises or busy places. Sometimes they may be having very high threshold for pain, right? But you know, and they would become quite anxious and agitated in those situations. So the symptoms of autism and autistic anxiety could be aggravated in certain situations. We know people with ADHD find it difficult to organize or to plan or to finish tasks. But if they're put in a very structured environment, in a very structured routine, and a very structured controlled environment, they will do very well. So they can change based on, the symptoms can change based on where they are. And they may have variable course across the lifespan, which means that the symptoms can change from one time to another. And I think that the important thing to consider is that once people are transitioning from one stage to another, with added responsibilities, with added expectations, with change in their environment, the likelihood is that the symptoms will change as well. And what would happen then is that the primary disability or handicap, which is important because of the fact that people have a handicap and a disability, once people have different problems in life or they face certain challenges, they may develop more secondary handicap or secondary disability. So you also have to consider that a person who has a primary disability could have more disabilities later on if they are not managed properly. In psychiatry, we have a list of symptoms, and we need to take those symptoms to come to arrive at a diagnosis. We know that in ICD-10, in DSM-5, there are symptom lists. But we'll see that in certain conditions, those symptoms are not present to the full extent. So there are partial symptoms, there are few symptoms and not the others. And those symptoms may come along some other symptoms. I'll give you some example. For example, in Down syndrome, people can have autistic features, not completely as they are represented in autism, but they may also have tetralogy of Fallot, hyperflexible joints, and other things. So whenever you're looking at symptoms which are not actually covering the whole width of diagnosis, and they're occurring with other conditions, you need to think about whether it's a genetic phenotype or not. So that means that the symptoms of autism or ADHD may not be pure ADHD or autism, but they may be presentation of a genetic phenotype. And the symptoms can be overlapping. So the same symptoms can be present in different disorders. For example, autism-like symptoms are present in West syndrome, which is an epileptic syndrome. Landau-Kleffner syndrome, again, an epileptic syndrome. And symptoms of ADHD may be present in Lennox-Gastaut, which is again an epilepsy syndrome. So you may have these symptoms, could have these symptoms in various syndromes. And this slide demonstrates that self-injurious behavior can be present in multitude of different conditions. ADHD-like symptoms, autism-like symptoms can also be present in a range of different disorders. Now this is a really important slide, and I would like everybody to focus onto this slide, because comorbidity is a really important matter once it comes to neurodevelopmental disorders. It's almost a rule that with neurodevelopmental disorders will come along a comorbid condition. at some point, if not now. And there are three kinds of comorbidities. The first kind of comorbidity, which is like type 1, is where a single etiology or a single cause leads to both or more disorders. For example, intellectual disability in chromosomal defects. I've given you an example of Down syndrome where trisomy 21, duplication of chromosome 21, or there are different other kind of options as well, can lead to not only intellectual disability but autistic-like symptoms and other physical symptoms. The same is true with head injury. So there's one common cause which is leading to multitude of disorders. Type 2 is where the etiologies are very different, but the two conditions commonly occur together. And an example is if somebody has got intellectual disability, they cannot brush their teeth properly. They may end up having problems with their teeth. If they cannot control their appetite, they may become obese, and they may have hyperlipidemia or diabetes or other metabolic disorders. And the third kind of comorbidity is where there's no relationship between the two disorders. So this is a very important area to consider once you're assessing comorbidity. And as you can see, that there's this is an example of comorbidity in autism. 53% would have an affective disorder, anxiety 50%, ADHD 43%, OCD 24%. So there's a high comorbidity in autistic spectrum disorder. And the same is true in ADHD as well. And the important one is this one. 60% would have seasonal affective disorder. So this is why it's really important to consider comorbidities. Any comments? Or should I move on? Yeah, go ahead.
When I differentiate epilepsy or autistic spectrum disorder, is a type 1 or type 3? Is a common reason or two different pathologies?
Exactly, and I think that's a very good question. So the question is that with epilepsy, sometimes it's difficult to find out whether it's type 1 or it's type 3, and it can be either of them, basically. Because I think it depends upon the genetic phenotype. So, for example, if there's a tuberous sclerosis, there's a clear diagnosis of tuberous sclerosis, you would have epilepsy, you have intellectual disability, you have autistic-like symptoms.
Type 1.
So that would be type 1, very clear. But sometimes it's very... Yeah, so basically that's that. But then obviously, usually in the UK we would have the option of doing a genetic analysis. I don't know whether you commonly have that here or not. So that could actually then highlight if there is like a genetic underpinning to both the syndromes. Right, common signs and symptoms in neurodevelopmental disorders. I'll just briefly cover some of the main things that you would encounter in almost all the neurodevelopmental disorders, very, very briefly. Executive dysfunction, emotional dysregulation, sensory integration issues, and behavioral symptoms. So I'm sure people would be aware of executive functions. So they are the set of cognitive processes which are required for cognitive control of behaviors and selecting and successfully monitoring behaviors required for attainment of chosen goals. So simplistically, they are like a pilot sitting in a cockpit, and that pilot actually has to take the plane from one destination to another destination and has to perform everything properly so that the passengers get to their final destination safely. So that is a pilot which actually is the executive function for us in our brains. So what these are? So these are the areas where they are located, but I'll just briefly touch upon that. That it's about impulse control, that people have impulses. So it's adaptation to do something or urge to do something. So executive functions, they resist that. Emotional control, regulation of emotion. Flexible thinking, ability to adapt and change thinking according to the context. Think about various options, not getting stuck to one thing. Working memory, so holding information in the short-term memory stores. Self-monitoring and evaluation. evaluating your performance, evaluating your performing tasks, then prioritizing and organization, and tasking station. So all of these features are executive functions. So they are controlling, they are organizing us, they are timekeeping, they are telling us not to get distracted, they are telling us to maintain focus on something and not to get distracted. They tell us when to initiate a task, when to finish. They help us to make decisions, problem solve. So all of these things are a part of executive functions, and they get impaired to variable degree in various disorders. So, if you look at this, this is the model for ADHD. So there is a deficit in arousal or activation. So there's something called as default mode network, which means that people, once they're not interacting or not, they're not using their mind, they are in a particular state of mind, relaxed state of mind. And in order to pay attention to something, they have to get out of that mindset. They have to go out of that default mode. It's like a sleep mode for a computer. The computer is sleeping and not doing anything, and you press that button and the computer awakes. I think there's a problem with this. Can everybody hear me properly? Because there's a problem with the mic. Yeah. I think I can just speak loudly so that everybody can hear it.
Maybe we'll try this.
Is that okay? Yeah, that's better. Yeah. Fantastic. So basically, default mode network is like a sleep state in the computer. That the computer is sleeping, you press the button, it activates straight away. So in the minds of people with ADHD, the problem is that they cannot activate quickly. They cannot come to arousal quickly to attend to something. So they cannot get out of that default mode network. The second problem with them is the mind wandering. So their mind keeps on wandering, going from one place to another, to another, to another, thinking, like daydreaming or imagining. And it's not that they do not like this phenomenon. Actually, they quite enjoy this. But their mind moves quickly from one idea to another, to another, to another, very, very quickly. And this state would be considered as something as daydreaming. So that's another thing to think about. And this is because of the fact that they have inhibitory deficits and working memory deficits and which are a result of these two phenomena. And then obviously there's a reward circuit issue as well, which is little to do with executive functions, but it's about them needing an immediate gratification of whatever they want. They want it now, and they cannot actually sustain a delay for long. The delay aversive, so they need something to be done right now, which leads to impulsivity. So again, dysfunction, executive dysfunction in autism. Again, the problems with flexible thinking. They're stuck to something and they would remain there. They would not move on. Emotional control, impulse control, very difficult. They find it very difficult not to give in to the impulsive acts, and they find it difficult to self-monitor themselves, and they have issues with their distraction. So these are the kind of problems you would get with impairment of executive functions: inattention, distractibility, issues with planning, organizing, reasoning, problem solving, issues with managing impulses, emotions, difficulty in initiating and completing tasks, working memory problems, and difficulties from learning from experience. So the important thing to learn from experience is that people have to firstly register something which they have encountered in the short-term memory, and then that has to go into the long-term memory stores, and then that needs to be recalled once they need to use that. They need to use that. So in ADHD, you would find that people would have problems with attention. They would not be able to remember, and they would not be able to recall easily as well. So that experience sometimes gets lost and it's not remembered. Emotional regulation, dysregulation is another important one, which means that excessive emotional reactions, frequent mood changes, irritability, volatility, and hot temper. And that's also one of the features of disorders. Sensory integration difficulties. Now, this is again a common feature across almost all neurodevelopmental disorders, but sometimes it's expressed, but then it's expressed according to a continuum. People may not have sensory integration difficulties, but sometimes they may have a lot of them. So what it is, that it's about the central reception, processing, and response to sensory stimuli. So people sometimes would hear the voices louder than usual. So whispers may come across as very loud noise to them, and it could disturb them. Or they may be under-responsive to stimuli. For example, people with autism may be under-responsive to pain, so they may not feel the pain. And then what tends to happen is sometimes they feel quite uncomfortable without actually seeking or craving for a sensory interaction to overcome their under-responsiveness. So if they're feeling bored, they would like to play with some object, or they would keep on fiddling with it, or they may like a certain texture of food, and then they would just because of the fact that they would like to chew it over and over again to get that feeling. So the sensory integration difficulties is also an important area to consider. And if people were coming to today's workshop this afternoon, I think we'll talk about it in more detail there, because it's a subject on its own and it requires more time. So there are issues with speech as well. I won't go into that. We'll cover that in our today's workshop. And finding challenging behaviors. As we know, behavioral issues are one of the key presentations in neurodevelopmental disorder, especially intellectual disability. And people who are working in this area would be very familiar with children or adolescents who actually come across with a lot of challenging behavior. And most common one is aggression towards others, and then the self-injurious behavior is the second one. So what actually leads to challenging behaviors? So people with challenging behaviors often have issues with communication, so they cannot express themselves properly through the language, so they act out to behave in a particular way to convey themselves. So it's about communicating a need, or if somebody puts a demand on them, somebody wants to do something and wants them to do something, which they want to avoid, so they could act out to avoid that. It may be used as a part of social interaction. They want to socially interact, but they do not know the right way of interacting with other people because they're not aware of social cues, the appropriate social rules, and they may do things which are inappropriate. Or they could be to fulfill a sensory need. We talked about sensory integration issues before. But they can also be a manifestation of things like pain or discomfort, because people may not be able to express the pain or discomfort, and they could act out or they could behave in a way to say that I'm in pain. They could be a manifestation of a physical disorder. For example, in intellectual disabilities, people with diabetes, if they go into hypoglycemia, they could act out. Environmental factors, they may be hungry, they may be cold, they may be being threatened in any way, or they may be a subject of abuse. People may be abusing them emotionally, psychologically, physically, and sexually. So all of these things could result in behavioral problems. So once somebody comes to you with challenging behaviors, you need to look at and evaluate all these causes. Now I have a couple of brief slides on treatment, very, very brief ones. The first one I would like to talk about is a concept of neuroplasticity, which is again something under research. There's a lot of work which is being done on it. But simplistically, it's the brain's ability to change, remodel, or reorganize to improve functions through lifespan. So one way of looking at neuroplasticity is the medication we use in different disorders, like we use stimulants in ADHD. What it does is it provides dopamine to dopamine-hungry synapses, and it actually improves the executive functions and other areas. And this is about improving synaptic transmission, upregulating them through medication use. And the other kind of neuroplasticity is about learning and skill acquisition through synaptic activation and creation. And this is very important because we talked about the phenomena of neurogenesis, and we talked about the phenomena of synaptic pruning. So if once you pick up these disorders early in the kid and you train them, especially our friends who actually are speech and language therapists, there may be some psychologists sitting here, there may be some art therapists or other professions who actually work in the area. they can do a lot of good work with these kids very, very early to improve their chances in life, because that's the time to do it. They're still growing, the brain is still very plastic, and you can do wonders with these children or adults. And I would actually come to this particular model, which is called Tirol model. It's a French word which stands for certain kind of wines which are grown, specialist wines, which require special environment, special growing conditions, special seeds of the grapes and whatnot. And this kind of gives you an idea of the development of a neurodevelopmental disorder. As you can see, there's a DNA state which actually transcribes into messenger RNA. Then it actually goes through a process of self-modulation, physiological process, neuromodulation, brain structure, function, cognition, and symptoms. So it is like a ground-up model from the very beginning to the very end. And these are given different levels, level 1 to 4. And it's been described that different kind of therapies would help at every level. So at level 1, which is the DNA level, we're talking about gene modification. On level 2, we're looking at biomedical interventions like methylations to methylcobalamin or folic acid, or nutraceutical approach, for example, the use of omega-3 fatty acids or high-dose micronutrients, antioxidants targeting oxidative stress or reducing inflammation. And level 3 is pharmacotherapy for actually symptom control. But a really important aspect are these level 3 to 4, because these ones, level 1 to 3, are basically targeting the impairment. They are actually trying to get over the impairment part of the problem. Whereas these ones, these interventions from level 3 to 4 are there to reduce the disability and social handicap, and they're really, really important. So, as I said to you that this is the model. Once we are looking at the neurodevelopmental disorder, one needs to think about a holistic model, a multimodal model for treatment. And that's the way to make sure that we provide best opportunities to our patients. Starting from pharmacotherapy, physical treatments, psychobehavioral therapy, to reducing disability and thus reducing the social handicap. So the takeaway home messages from this presentation are that mental and behavioral presentations are common in neurodevelopmental syndromes. They are a result of a complex gene-environment interaction. They can be classified as global and local. Comorbid conditions are common. And always try to think about a multi-axial way of formulating them. Most importantly, early detection, intervention, multimodal treatment are crucial for a good prognosis. With this, I thank you all.